Let's continue with our discussion on L angle repair. What we have done in the previous video, and let's go back. We have an L angle. Why I choose L? Because it's easier for me to explain. As well, this is also one of the common parts in the aircraft structure. We have crack, so we cut this area off, and then we install a filler, and then we have a double plate. We have 3 rivets, so this plate is a double. If you look at from cross section, we have lost this area, and then we put in a doubler. So this doubler will take up what is lost. So we also install a rivet. So what we need to do is we need to determine how much is lost, and when you put in the doubler, whether the doubler will be able to carry the load. So what is lost here? Okay, loss area load. We have agreed that 405 megapascal. This is strength of this material here. This one is aluminum alloy 2024 T3. So the strength, the shear stress, this one is FTU of this aluminum alloy 2024 is 405 megapascal. Megapascal is also Newton meter square. So now we have to multiply by the area, cross sectional area, because we're talking about the load applied in the axial direction. So here is tensile. So we lost the area, the ability to carry the tensile load, because we lost this area. So only this area now is fully functioning. And then how much is lost? So here we have said earlier is a 20 mm, and the thickness is 1.6 mm. So now we have 20 minus 1.6 divided by 1000. We have to convert to meter, and now we have so this is 20, thickness is now is 1.6, and you have to multiply by the thickness is 1.6 millimeter times 1.6 over 1000. So what do we get? What do we get? Let's calculate. So that's 20 minus 1.6 divided by 1000 times 1.6 divided by 1000 times 405 million Newton meter square. 3 1 2 3. So we have 11,923.2 Newton. So this is how much loss, because of we lost this area. So now our first attempt is to rule of thumb, material similar, thickness we use 1.8 mm as we have earlier followed the standard recommended practices, which is 1 gauge higher, but not necessary this will solve the problem. We have to check first. So we have thickness 1.8. What we get is the doubler strength. Doubler strength, we have agreed 405 megapascal. Now you multiply by, here is still 20. This here is basically 20 minus 1.6 mm, because this remain 1.6. So 20 minus 1.6 convert to meter. Now you have to multiply, because the thickness is 1.8 over, so here is, because you have chosen the thickness is 1.8, so this from here to here is 1.8, so the area here is 20 minus 1.6 here times 1.8. So it will be the doubler strength. So what do we get? 20 minus 1.6 by 1000 times 1.8 divided by 1000 times 405, 123 is 13,000. Okay, 13,413.6 Newton. So obviously now that 1.8 are able to give you 13,000 Newton. We lost 11,000, so we still have margin, means that it's acceptable, but we have to check the factor of safety by dividing 13,413.6 over 11,923.2. So divide by 11,232.2, you got 1.19 as a factor of safety. So it's still less than 1.5, which is required by the certification requirement.